In this lesson, we're going to look at how we name different enantiomers. This is going to be fairly important to recognize the differences in enantiomers. So pay close attention to how we do this. It will require some ability to either model things in 3 dimensions in your head, to be able to see things from a different perspective, or to be able to flip things back and forth. And we'll look at both ways. But just to get started, let's look at what R and S actually mean. When we have these 2 enantiomers of each other, notice these are the mirror images of each other, and there's no way these could be superimposed on top of each other. We're going to name these by looking at that same method of determining order of priority that we used when we were looking at the stereoisomers. So in order to do that, I'm going to look at the atomic number of each of my constituents. So I've got iodine, chlorine, hydrogen, and an oxygen. This hydrogen is connected off of the oxygen. So let's go ahead and give each of those a number. Hydrogen, that's got the atomic number of 1. Both cases, it's going to be the same. Oxygen, that has an atomic number of 8. Chlorine has an atomic number of 17. And iodine has 53. If you'll remember correctly, our higher number wins. So iodine has our highest priority in both cases. Okay, so let's use blue. So iodine is our first priority, our number 1 priority. After that, chlorine comes in second. Oxygen in third. Hydrogen in fourth. Now notice, the priority, the number 4 priority, is to the back of the molecule. You can imagine that this is sticking out of the board like this, and this is sticking into the board. We're always going to be figuring this out with our 4th priority, our highest, our lowest priority. Our number 4 will be to the back. We always want to have our 1, 2, and 3 facing forward. Okay, that's very important. This will not work otherwise. So once we do that, I'm going to erase my atomic numbers here so we can just focus on the priority order. Once we do that, we can see I've got a 1, 2, 3, 1, 2, 3. I'm going to draw a line going around this. This is 1, 2, 3 going this way. This is 1, 2, 3 going this way. So this would be clockwise. This would be counterclockwise. Another way we could think of that is just like when you're turning in a screw or turning a bolt, righty-tighty, lefty-loosey. So this would be to the right. This would be to the left. This is where our RS naming convention comes into play. I'm just going to look at my paper to make sure I pronounce these the right way. R and S stand for rectus and sinister. Rectus is Latin for right, and sinister is Latin for left. So this is right, which is easy to remember because it's R in both cases. Sinister is harder to remember because it's S. But so we're going to have R and S, rectus and sinister. And so if we look at this first one, this one right here, I'm going clockwise. I'm going to the right, so that would be rectus. So this would be labeled as the R enantiomer. All right? This one here, this one is going counterclockwise or going to the left, so this would be the S enantiomer. That's how we're going to name these. Okay? Next, I have 4 carbons set up. Each one has a hydrogen pointing into the board. This first one has a fluoro group, a chloro group, and an iodo group. All right? I'm going to number these. I'm going to figure out my RS convention. And then I'm going to flip these groups around so that we can get a good idea of what happens when I just flip 2 of these. We're going to see that there's only 2 ways this can go. And that's going to help us to be able to make rearrangements when our fourth group is not pointed towards the back. So first, fluorine, iodine, chlorine. Fluorine has an atomic number of 9, chlorine 17, iodine at 53. So iodine clearly comes in first, chlorine comes in second, fluorine comes in third, hydrogen fourth. So I can see that I'm going clockwise. So I'm going to the right here. So that would be the R convention. Okay? Now what happens if I just flip two of these groups? Any two. I'm going to flip the iodine and the fluorine. Okay? I'm just going to put those on opposite sides. So my chlorine stays in the same spot, but my iodine goes on top. My fluorine goes to the left. Now if I do that and renumber, now this is still 1, this is still 2, fluorine is still 3, but now my arrow goes in the opposite direction. So this would be the S enantiomer. Try this out for yourself. Any one of these that you flip, it doesn't matter which two you flip, any two that get flipped will cause this to become the opposite enantiomer. Let's look at the next one. If I flip a couple of these back, let's flip the fluorine and the chlorine now. So now my fluorine goes here. It's a terrible F. There we go. It's a little better. Iodine is still on top. I'm just flipping my fluorine and my chlorine. Now once again, iodine is number 1, chlorine is 2, fluorine is 3. And now I'm going clockwise. I'm going to the right. So this becomes the R enantiomer. So just flipping two groups causes this to flip its orientation. There's only two options for the orientation. It's either going to be clockwise or counterclockwise. So let's look at one more. Let's flip these back. Let's flip iodine, fluorine. Iodine, fluorine, chlorine. Now just looking at that, I can see that this and this are flipped. My fluorine is back on top, but my iodine and my chlorine are flipped. So I should have, this should be the S enantiomer because I've just got two of these that are flipped. The others, the fluorine and the hydrogen, are in the same place. So let's double check that. Iodine is 1, chlorine is 2, fluorine is 3. That would be counterclockwise. Going to the left, that would be S. There we go. Now we're looking at our challenge. We've got our hydrogen pointing straight up. If I number these with my priority, hydrogen being the atomic number of 1 is definitely going to come in fourth. Bromine has an atomic number of 35. That's going to beat out carbon and nitrogen. Number 1. Carbon has an atomic number of 6, nitrogen 7. So nitrogen gets 2, carbon gets 3. If I look at this, this could be deceptive. If I try to go 1, 2, 4 and go around like this, I would call this R, but that might not necessarily be the case. Because even if I flip my carbon and my nitrogen, making this a 3, I would still think of this as 1, 3, 4, and I would still think that that's the R enantiomer. The point being, we're not going to be able to tell if this is the R or the S enantiomer without that 4 being pointed away from us. So there's two ways to do this. One way is to consider this in 3 dimensions. If I'm looking at it like this, I've got my bromine here, my carbon here, my 1, 2, 3. If I point that up, 1, 2, 3, that is counterclockwise. That would be sinister. If I'm struggling to do that, I might need to make some models to help me out. You can think of it this way. You can think of here, red is bromine. This green will be nitrogen. This orange will be the carbon. Hydrogen standing straight up. So I would need to think of this as flipping this way. Then I would have 1, 2, 3. To the left, sinister. Now what if I suck at figuring these things out in my head? What if I can't flip this in my head? Well, good news. That's the reason we just went over the last thing we did. Because if I flip any two of these groups, then it's going to flip the enantiomer. So if this is supposed to be S, let's watch this. This is supposed to be S. We saw that because I was able to flip that just using a little model. Okay? So this is supposed to be S. If I flip any two of these groups, it will flip to the R enantiomer. So I'm going to flip two of these, and I'm going to turn this into the R enantiomer. And we're going to see that I'm then able to figure this out for sure. So I need to flip two groups. I'm going to flip my group at the back with hydrogen. So if I do that, I'm going to get my hydrogen to the back, my CH3 on top. So there's my methyl, there's my hydrogen. I just flipped these two positions. That's it. Now let's put our bromine back on and our amino. Now we renumber these. Br is 1, amino is 2, is 3, hydrogen is 4. Now I could look at my counterclockwise versus clockwise. I could see this one is going clockwise. This is the R enantiomer, which leads me to believe that the one that I started from was the S. So if I've got a situation where my fourth priority group, whatever it is sticking up or sticking out or sticking off to my right, I can just flip that with the group that's facing backwards, figure out my position, and then remember that I flipped it. So I can come back to the S. Okay? Let's do one more practice run with that in order to flesh that idea out. All right. Here, I've got an oxygen, I've got an ether coming off here, I've got a chloro, bromo, hydrogen. Numbering our priorities, hydrogen, number 1, obviously it's going to be in 4th. Better. Bromine, 35, beats out carbon at 17. Bromine is going to be number 1. Chlorine is going to be number 2. Oxygen with 8 will be number 3. Once again, my number 2 group is facing into the board. I'm not able to figure this out directly. So let's try just flipping two groups in order to figure this out. So I'm going to flip my chlorine with my hydrogen. I'm going to put that number 4 group facing into the back. Let's put our hydrogen on the back. Let's put chlorine right. Our ether group is still in the same spot. And our bromine is still on top. Now when I number these again, my bromine is number 1, my chlorine is still number 2, and it's number 3, hydrogen number 4. So now I can figure this out. Now I can do my rotation. I'm going to go clockwise. So this is my R, my rectus. And that means that this must be the S. This must be the S orientation because I flipped two groups. This has to be the S orientation. And now let's use a model just to prove that. I'm just going to set these aside. So I've got my model right here. Let's say I usually use the yellows as hydrogens. The red will be my oxygen. Then I've got here this. Orange is chlorine. Green is bromine here. So when I look at it this way, when I look at this model, this way. My hydrogen is sitting out here. This is my 1, 2, 3. So when I go around like this, I bring it up, I go around like this. Right? See that? Go around like this. So that would be to the left. It's counterclockwise. So that would be the S. So using a 3D model, I can prove that this is the S orientation. If I flip two groups in order to figure it out, I just flip it back to know my original orientation. So now we can figure out the R, we can figure out the S, and this is going to be for every chiral center. Every single chiral center is going to have this same exact orientation, okay?